So for part A, the cost of producing 100 units, I'm going to plug 100 in for every x. And using your calculator, you should get 806. Now, to find the average cost and the marginal cost, first I need those equations. The average cost, each piece of the equation needs to be divided by x, because x is the quantity. So I'm going to switch my variables here. And when you plug in 100 to the average cost, you should get 8.06. Now there is a shortcut. Because we found the cost of 100 units, we could also take 106 and divide by 100, because it's 100 items. Now for the marginal cost, the derivative of your cost function is 0.04 plus 0.0004x. When we plug in 100 to find the marginal cost, or the derivative of 100, we get 0.08. We're going to do the same thing for number 2. The cost of 100 items. So for the average cost of 100 items, I could either take my cost and divide by 100, or you can find the average cost formula, divide each term by x, simplify, and plug in 100. My marginal cost, the derivative, but then I have to plug in 100, and my answer is 130. So compare the marginal cost with the cost of producing the 6th motor. So first I'm going to find the marginal cost. I'm going to rewrite my cost equation so that it's easier to find the derivative. So since this is divided by x, I'm going to make it an x to the negative 1. So now my marginal cost, the derivative, is 50 minus 100 x to the negative 2. And I'm going to rewrite that so that my exponent is positive. So the marginal cost, C prime, of 5 for the 5th unit is $46. Now, the cost of producing the 6th unit, we're going to compare the cost of the 6th minus the cost of the 5th and see what that approximately equals. The cost of the 6th unit, when you plug 6 back into your original cost function, it's $416.66 as a decimal repeating, minus the cost of 5 is $370. So that approximately equals $46.67. So you can see finding the marginal cost of the 6th motor is a little bit more than the marginal cost of the 5th. Okay, so again, we're going to have to find the derivative of the cost function. Plug in 100 because it wants to know the marginal cost of 100 ovens. Now comparing that for the cost of the 101st, when you plug in 101 to your original cost, then we're going to subtract when you plug in 100, and that is $116.11. Okay, for the revenue, we're going to make $18 per item. So our profit is revenue minus cost. So that's 18x minus the entire cost function. This negative needs to be distributed to each piece. And as a final answer, I'm going to get 12x minus 500 minus 0.02x squared. Maximizing profit. So here's our optimization problem. I need to find the derivative or the marginal profit, the derivative of the profit function. And then I'm going to set that equal to 0 and solve for x. So to maximize the profit, take my first derivative, set it equal to 0. I'm going to add the x term to the other side. So we get 12 equals 0.04x. We're going to divide by 0.04. So we get x equals 300, and we are producing calculators. Now, the daily profit that is maximized, I'm going to take 300 and plug it back into my original profit equation up here, because I want to know the actual profit. And that is $1,300.